Okay, so welcome everybody. This is the October 2014 edition of the High Availability and Disaster Recovery virtual chapter for SQL Pass. We really do appreciate you all spending your lunch hour with us. So some meeting logistics today for the meeting. We are on Twitter. We're going to use the HADRVC hashtag. This is a conference bridge free webinar. Everything's going through GoToWebinar. We have everybody except the presenters on mute. If you have any questions at all, feel free to ask them at certain breakpoint or really throughout the entire presentation. At the end of each HA topic, John will be taking some of the questions here. If they're really in depth, we're going to save them until the end, and that way we make sure we don't run out of the time. It is recorded, so if you want to use this for reference or for continuing education, it'll be available up at hadrvc.sqlpass.org. And when we wrap up, we will have a survey to get some feedback on the presenter and how we're running things, because we're always interested in looking to do things better. We do meet monthly on the second Tuesday at 1 o'clock Eastern, 12 noon, etc. Future meetings. So we have John Sterrett with Introduction to High Availability for SQL Server today in November on the 11th. So that's right before the summit. Or actually right after the summit. We have Intro to Log Shipping with Brandon Leach, awesome presenter. And December 9th, we have Multi-Subnet SQL Server Clustering and Availability Groups with another awesome guy, Edwin Sarmiento. Should be a great setup. For those of you that are looking for continuing education with a conference, the SQL Pass Summit 2014 is coming up. It is my favorite event of the year. I will never, ever miss it. It's absolutely incredible. It's 4 days, 5 days if you count some pre-cons in there. Right now, it's actually a little bit higher than that dollar amount now. Register as soon as you can. It's in 3 weeks. So get connected. Now ask your chapter leader for your local user group or ping us, because I think we have a discount code as well, to get a discount of $150 off your registration. We are one of many of the SQL Pass virtual chapters. So this is the HADR one. There's a lot of other ones there that are industry specific, they're language specific, or they're topic specific. They're all fantastic. I spend a lot of time every month listening in, and a few of these I take some time to contribute to. So I stress that if you like this one, check out some of the other ones. They're all fantastic. There we go. Okay, so there's the updated slide. So until October 31st, the price is $2,095 with that discount that you can get. So we have some upcoming meetings here. We've got, I know the virtualization one, a lot of these are past. Coming up soon, Global Spanish, Business Intelligence, a lot of other ones coming up. Just check the virtual chapter listing on the site there. If you're not familiar with SQL Saturdays, they are one-day free regional events really all over the country and all over the world. Upcoming, we've got Providence, Rhode Island, Minnesota, Tampa, and Salt Lake City, and we've got a lot of really cool ones around the world too. So check SQLSaturday.com, register for the events. They're fantastic. We have a lot of fun speaking at a bunch of them. If you're interested in volunteering for Pass, especially with the summit coming up, go under My Volunteering section of the My Pass profile, so just sqlpass.org and log in there. Volunteer. It is very, very rewarding. It's a fantastic community, so I cannot stress enough. Get involved with the community. It's awesome. If you know of anybody who has really gone above and beyond over the last month or two that deserves to be somebody nominated for the Pass Outstanding Volunteer Award, send it in, because every year at the SQL Pass Summit, the person who really has really done the most for the community gets a really big award. It's called the SQL Passion Award. Again, volunteer recognition is where it's at. Go ahead and send that in. If you're so as you are a member of this webinar, you get a free membership into the SQL Pass community. So go check it out. They're on LinkedIn, Facebook, Twitter is @SQL Pass, and just sqlpass.org. So today's presenter, a great friend of mine, John Sterrett. He's a group principal and senior consultant with Linchpin People. Previously, he was a senior DB admin advisor with Dell, responsible for a lot of their stuff. The guy speaks all over the place. He's an absolute guru at performance tuning and HA and DR topics. He's also a past regional mentor and does a lot with the West Virginia SQL Pass user group. So I would like to turn this over to John.
Thanks, David.
And there you go.
All right, are you able to see my screen?
I can. Looks good.
Excellent. So here's the abstract for this hour today. We're going to try to keep this at 100 level, going through a lot of the feedback of the evaluations from everyone who's attended our high availability disaster recovery meetings. It was mentioned that there was quite a few people that were wanting, high level basic, what are the high availability features for SQL Server and how can you use them, and what are some pros and cons with them. So basically I took that and built a presentation for everyone for that. So a little bit about me. I am the co-leader of the High Availability and Disaster Recovery Virtual Chapter with David. Just like David, I'm very passionate about the SQL Server community, and you can see me all over the United States at SQL Saturdays, user groups, the PASS Summit. Some areas that I focus on, which David's mentioned, is performance tuning and troubleshooting. I love performance tuning. At the same time, I also have grown to love high availability and disaster recovery. I've worked on previous infrastructures for Dell, for Comcast. So I've done a lot in big enterprise corporations and also some mom and pop shops, getting them set up so that way they can have an actual plan for being highly available and to have plans to go through when disasters do occur. If anyone wants to reach out to me, you can do so via Twitter. John Sterrett, just my name is my Twitter handle. Also, you can do it through email at johnsterrett@linchpinpeople.com. For anyone who's not familiar with the Linchpin People, we're a boutique consulting company that does a lot with the SQL Server and even Microsoft space now with a lot of development. But I work with Mike Walsh and some other great MVPs to take care of the database practice, so focusing on the high availability and disaster recovery performance issues. So here is today's agenda. First, we're briefly going to talk about, what is HA, what is disaster recovery, and why they don't equal each other. It's kind of a misunderstanding I see when I talk to quite a few people at a lot of conferences and events that I go to. From there, we're going to dive in and take a high-level look at all the features that you can use inside of SQL Server to help you with your high availability. So we'll start off with log shipping, then we'll go into database mirroring. We'll touch up briefly on transactional replication, and then we'll dive into failover clusters and availability groups, and then wrap up with some questions. So we'll go over some basic definitions here. So what do we mean when a system is highly available? So what this means really is that it is highly available, that there actually are plans to where if the server goes bump in the night, there are other things that can automatically happen or happen with manual intervention that will keep the data online so that way the end users can use this data through their applications with a minimal impact to them as possible. So what does it mean to have a disaster recovery system? So this means that you actually have plans for specific disasters that potentially can happen, so that way you're well prepared in advance and you actually have a plan that's written and documented and tested, so that way whenever these disasters could occur that you're well prepared for them. So looking at Wikipedia, high availability is a system design approach to associated servers implementation that ensures prearranged level of operation performance will be met during a contractual period. So what this really means in a high-level nutshell is basically you have a system design that will allow for minimal downtime. So this all goes back to the business and what kind of risk you can assess for the amount of money you're able to spend on highly availability. But this is basically giving you a design that will keep your system up to meet your needs. So a couple examples of disasters. So my wife's parents were both born and raised in New Orleans. In fact, one of our aunts actually worked in the children's hospital that stayed open through Katrina. So obviously this is a disaster that's something that you should take in effect for, even though the chances of you running through a disaster like this, depending on where you live, could be small. You know, if you lose your data, you could be out of business very quickly. Here's the disaster, though, that I really see out in the field the most, and it's ones that a lot of people don't think and have a plan for. So what you'll see here is this is actually a delete statement, where you can see here I even circled around where the delete and the from clause is highlighted, but the where condition was actually forgotten. So in this case, we've actually deleted all the data in a table instead of actually just deleting the small little subset that we have in our filter. So this is one where especially you have very large databases that you really need to factor into, because these kind of disasters can happen a lot more frequently to you than some of the bigger disasters. And a lot of times I see this type of disaster not included in disaster recovery plans. And we'll talk about how you can use log shipping to kind of help you with some very large databases so you can quickly pull data while you're restoring at the same time. So once again, going over disaster recovery, as I mentioned, risk management. So this all comes into play of, you know, what kind of risk are we allowed to consume with our plan that we're building? You know, how long are we going to agree to spend in order to bring our databases back online and actually build plans that will include a lot of the high availability features to help you meet the needs that are set up from your plan that go along with your risk management. The big key here is usually backups are not enough by itself. So you usually need a combination of quite a few things to get the high availability disaster recovery that you need. So once again, here are the options that we're going to focus in today. And once again, we're going to keep this very high level for today. We're going to go over what is log shipping, how can we use log shipping, what are maybe some things to look out with log shipping. We'll go over database mirroring the same way. We'll do a quick dive into replication, mainly focusing on transactional replication. Then we'll dive over into Windows failover clustering with failover cluster instance and also always-on availability groups. So in a nutshell, log shipping basically is 3 tasks grouped together, regardless of whether you're doing this natively inside of SQL Server or you're using a third-party tool to help you with this. You're basically having transactional log backups that are occurring. So step 1 will be take a transactional log backup. Step 2 is actually now physically copying this log backup over to a secondary server. And step 3 is restoring the log backups. And these are all independent steps. So using the native set of tools in SQL Server, these would be SQL agent jobs. So there's 3 separate ones. So that way, for example, it's not a one-to-one relationship. So if you actually had, for example, 3 transactional log backups occur, you could actually have the copy process copy once to copy those 3 backups. And the same thing with restore, to where the restore will restore all of the log backups that are in the queue. So an interesting story with log shipping, this is a standard edition environment. When I actually first used log shipping myself, it's when I was beginning of my career, when I was working with a really big application, a very large database. It didn't have data that changed a lot. And even though we were using standard edition and the data center which we were moving this to was pretty far away, the actual plan that was being talked about for using our migration was to just put the servers in a truck, drive the truck across the country, and hopefully we'll hit the power switch and everything will be fine. So one of the very first things that I did from hearing this plan was think, well, there had to be a better way when I was starting out as a DBA. And log shipping was a great way to do that. So the link down here, which I'll have in the PowerPoint, which at the very end we'll have the link to where you can download this PowerPoint. This will just walk you through a step-by-step example of how you can configure and get log shipping going. So there's a couple of things I want to point out with log shipping that a lot of people don't realize when they get started with it. You actually have some options. So the first thing we're going to point out on the first image that you see in the top here is you actually basically have 3 different options for how you're doing the restores in the 3rd step of log shipping. So by default, a lot of people will just use no recovery mode. What this means is the database is sitting there where you cannot access it. When I say access it, you cannot query against it. You would just be able to use it if you wanted to recover and bring that database online. So the interesting thing is you actually have standby mode here. And standby mode will allow you to read the data. But if you've ever done any restores, you're going to know that you actually can't read data while you're doing your restore at the same time. It'll block it. So that's why we have 2 options here. So the option that's selecting here basically states, we're going to allow readable queries, and if someone is currently accessing the database, then we're not going to do the restore, and we're just going to hold it. So we'll retry it again the next time. So if you wanted to actually block out users and make sure that you have your data restored up as frequently as you can, and you could click there in the checkbox, and that would disconnect the users. So that way you could still query it, but you may get kicked out while it's doing the restore. So the next thing I want to show at the bottom here is actually the schedule. So here's a key thing about log shipping. Without having an impact on the transactional log here, because all we're doing is we're taking the backups, we're not scanning the log or anything like that with some of the other high availability features, you can actually schedule when this restore job happens. And you can have multiple secondaries for log shipping. So you can have a database, and it can be log shipped to multiple different locations. So if you have a very large database and you're worried about that scenario where I showed you where I've actually seen some people lose their job because of it, where you delete a statement and you're not able to recover quickly, what may help you here is you can have one of your secondaries in log shipping to be delayed enough to where periodically you could recover data. You wouldn't be able to recover it all. You only get it up to the point in time of that last restore. But that could be an option to get a lot of data back while you're restoring this very large database, and then can just move in the data that's been missing. So a couple of things to note about log shipping. Transactional log backups, they occur on the primary and then they get shipped on over to the secondary servers. As I mentioned, based on how you configure log shipping, data could be read on the secondaries. So as long as you have it configured to where you're doing standby, you can read from them. And you can also even have a monitor that you can set up too. So that way you'd have your SQL agent alerts, and they can perform actions based on the thresholds of how long it's been waiting since the last copy or the last restore. So another thing I want to point out with log shipping is if you actually right-click on the jobs, a lot of times you'll see it's always successful because the job is successful, but it may not actually be copying and restoring the databases as you're expecting. So one thing I want to point out to you is this dynamic management view that you can run called SP Help Login Shipping Monitor, which will give you an exact look at where log shipping is. So it'll get you the primary and then all the secondaries that are getting the data shipped to it. And it'll let you know exactly, what was the last backup that was copied or the last backup that was restored, and how long has it been since those actions have occurred. So once again, log shipping, here are some pros and cons for log shipping. Standard edition, so you don't have to have an enterprise edition to use log shipping. It supports multiple targets, so you can have database logs being shipped to multiple different databases on different instances and different locations. Depending on how you configure it, you can have readable copies that you can access, depending on how you set that up, whether it's do the restore and kick everyone out, or whether you can choose the opposite, which would be to allow people to read and you'll retry on the next restore job. The nice thing here is you can delay your restores, so you can actually have a copy to where you can say only restore at these periods of times, so that way in case you have a scenario where someone accidentally deleted data, you could pull it back from the readable secondary copy while you're doing that big restore to get the data back. Once again, it's a manual, so some of the cons here, one of the biggest ones is the manual failover process. So for example, if you need to fail it back over, you'd have to basically break log shipping and reconfigure it. So with that, we'll move over to database mirroring. So the difference between database mirroring is this is now actually on the transaction level where log shipping was taking the log backups. So in database mirroring, what's happening here is we're actually going through the transactional log, and as data is changing, we're sending that over to the mirror and hardening that. And we have a couple of modes that will have impact on how database mirroring will work. So for example, if you want an automatic failover, so that way you're going to automatically fail over whenever the server would go down, you would have to use synchronous mode here with automatic failover, and that would end up using what's known as a witness. So the witness is another instance that could be any instance including express that's used to ping the servers to know, to kind of have a little quorum to say, this went down, but the other server's up, so we can fail over. So the one thing to note on that is with synchronous mode, you're actually, whenever you do your commit on the primary, it's going to actually take that and commit it on the secondary and send the acknowledgement back to the primary before it's actually really committed. So that, due to performance, if you have a very high transactional system, that may end up being a problem for you. So in Enterprise Edition, we actually have high performance mode, which is asynchronous. So that way we can commit on the primary, and then it just gets sent over to the mirror and it gets acknowledged. So it's not actually holding until it gets committed on the mirror. So and here's kind of showing you step by step what would happen between synchronous mode, and we'll also look at asynchronous mode. So as I mentioned on the principal, so this would be your active copy. Whenever you have an insert or update, it goes into the log, it's going to end up being read and then be shipped over to the mirror. So it hasn't been committed yet, so it's still holding and waiting at this point in time. So on the mirror, it'll be written, and then we'll send the acknowledgement, and the transaction will be committed on the mirror itself. So it's still not committed on the principal, but it's committed on the mirror, so that way if you had a failover, you could automatically fail over and you wouldn't have data loss. So finally, once that completes on the principal, now the acknowledgement will be received, and now we can commit the transaction. So on asynchronous, and once again, asynchronous here, this is an Enterprise Edition feature only. So if you have Standard Edition, you could do synchronous, which is also known as high safety, where inside of Enterprise Edition you could do asynchronous, which is also known as high performance. And this is how it works for high performance, also known as asynchronous mode. When we actually insert our data, it'll go into the log, when we'll end up reading it from the log, and it gets committed there on the principal. So there's no wait on it going to the mirror and acknowledgement coming back. It actually will commit before it sends it over to the mirror. So it'll get sent over to the mirror. You have your acknowledgement that goes back to the principal, and then it'll commit there, and the principal will acknowledge that it received, that it was committed on the mirror. But it's high performance because it doesn't have the lag of waiting for your transactions to go and be committed on the mirror and have that sent back. It's going to go ahead and commit it on the principal before it sends it over to the mirror. So with database mirroring, here are some things that you'll want to know about it. That it is deprecated inside of SQL Server 2012, which means in a future release it will no longer be there because it will be replaced by availability groups. But like I mentioned, if you have Standard Edition and you're working on versions of SQL Server before 2012, this could be a great feature that can help you out. Some interesting things to note is that database transactions are compressed while they're being shipped in 2008 and plus. And then also that you have the difference between high performance and high safety, which is also known as synchronous or asynchronous, where high performance asynchronous is an enterprise-only feature. And the optional witness can be used so that way you can have an automatic failover. So a warning that I like to point out too, looking out from books online here, is if your current instances have high CPU usage, database mirroring an automatic failover may not be the perfect thing for you, because you could see quite a few failovers occur just because of the CPU usage. So this is one thing I always like to point out with people while I'm talking with them about high availability features, because it's actually recommended by Microsoft. If you cannot keep 50% free utilization of CPU, they actually don't recommend you using high safety with automatic failover. So once again, here we'll dive into the pros and the cons here of database mirroring. So the witness can be any addition if you want that automatic failover. You get page level corruption fixes, which is also a great thing. So for example, if you had a page that got corrupted and the page on the mirror was good, it'll automatically fix it for you in Enterprise Edition. You don't require Active Directory. You can actually use certificates, which will make setting up mirroring a little bit harder, but you don't have to actually use Active Directory, which is a nice plus. It's a database level high availability feature, so this is something that you would have to set up for each database, and you could not do this for system databases. And high safety, as I mentioned, only requires standard edition. So some things that are so great about database mirroring is you cannot mirror the system databases, as I mentioned, and automatic failover does require that witness. So you have to have a third instance somewhere that's being used to get automatic failover to occur. Your databases must be in full recovery mode. If you want high performance, it requires the Enterprise Edition. And remember, this is database level only. So anything you have in the instance that's required for those databases, they need to be maintained on both sides. So all of your SQL agent jobs, your logins as an example, those need to be maintained on both sides. So next we'll take a quick look at replication. And we're mostly going to focus on transactional replication here. So replication, this is actually one feature here where you have to physically install a separate component in order for it to work within SQL servers. When you actually go through your installer, SQL Server replication would have to be checked in there in order for you to be able to use it. And we'll go over quickly how transactional replication can help you. One of the main advantages of transactional replication is you could actually use this to keep a subset of a table highly active. So you can actually replicate using filters within the data that exists within articles, which we would refer to as tables. So the way how transactional replication would work is you have your application that's doing its reads and its writes and its updates to the database instance, which this database would be our publisher. So publisher is just going to send the data down. There'll be a log reader agent that will probe the transactional log and take these changes and send them out to the distributor, and they'll be stored in a distribution database. And then this distribution database will then use the distributor agent that will ship all this data out to all of your subscribers. So like log shipping, you can have a one-to-many relationship where you have your one publisher and you have multiple subscribers. And this is on a transactional level, so relatively quickly can be used to send your data across to your subscribers. So here are some pros and cons for replication, transactional replication. You could do this for a subset of your data. So if you have some very large databases and you only have a subset of your data that's really, really critical to be available even within a table, if you wanted to, this would be an option to keep that highly available. This also can be done with simple recovery mode. So when you look at all the other features, you actually have to be in full or bulk log because, for example, to do log shipping, you have to have a transactional log to ship. So with replication, this is one feature where actually you can still probe the log and it'll hold it in there in simple recovery mode. Standard edition is able to use transactional replication. Once again, some cons to transactional replication. The failover process is manual. It's known to be fragile. You can break it very easily. A perfect example of breaking transactional replication is if you're actually inserting data into the subscriber and it prevents the distribution agent from sending data. That's a real easy, common way to where I see transactional replication being broken. And it can be a little complex compared to some other options out there. Hey David, have we had any questions that have popped in at all over log shipping or mirroring before I dive into the failover clustering and availability groups?
Right now, I don't see any. If anybody has any questions, feel free to enter them in the either the question or the chat window here, and we'll be happy to answer them.
All right, so with that, we'll go ahead and we'll jump over into failover cluster instances. So at a very high level, you're going to have a Windows failover cluster, which is represented here by our red box. Now you're going to have your instance. So even though we have two nodes, which the two nodes would be your two actual servers, whether they're physical or virtual, you're going to have your whole instance that's going to be inside of a node. So everything we've looked at so far has all been database related, where a failover cluster instance is actually going to take care of the whole entire instance. All the system databases, all of your SQL agent jobs, your logins and everything, it's all going to be contained in the instance. And the instance itself will bounce back and forth between the nodes. Also here you'll have your virtual name. So you have one individual virtual name and AD computer object that you will connect to and use for your application so they connect. So regardless of where the instance is, whether the instance is on node 1 or node 2, the virtual cluster name will be used to connect and will route everything to the instance so that way it can be accessed. So how does Windows clustering work with SQL clustering? As I mentioned, we'll have two physical nodes. So this, in this case, would be the servers that will end up being used by the Windows failover cluster. So inside of the cluster, we'll have several groups that you may or may not have. For example, Windows clustering will actually manage the quorum and manage the resources needed for the cluster itself, where we'll have a SQL Server group which will actually have our instance. So as you have multiple nodes here, you can also have multiple instances. Also MSDTC or file server, any other applications would be their own separate groups. Then the end users then would end up going through them, through the cluster in order to access those groups. But each one of those groups are going to be completely separate. So completely separate storage, completely separate groups, completely isolated from each one of them. So if you're using failover clustering, especially before Windows 2012, you're going to need shared storage. So even on Windows and SQL 2012. So even though in Windows 2012 they actually added functionality in failover clustering, so that way you didn't have to use shared storage and you can actually do SAN replication in between the two. One thing that I want to note here is SQL Server didn't have any updates to handle that. So 2012 is where you could really take advantage of not having to have shared storage. In Windows 2012, you can actually now use the standard edition of the OS, where before you'd have to use Enterprise. And if you're using standard edition, a lot of people don't realize this, but you can still do SQL Server clustering. You're just limited to only having a 2-node limit. So basically, you'd have an instance that would be on one node, and you'd have the second node for failover. And then also, we'll talk in more detail about the quorum and how that works, so that way you keep your failover cluster online. So here's taking a little bit of a dive into the configuration that you would see for a simple a single instance on 2 nodes. So for example, this configuration could be done in standard edition. So a couple things to point out here that you'll see right there at the top here, your status. So you can see that the group is online. You can see who the preferred owners are. You can also see exactly who is the owner in the gray box up top. So from there, now we can see some of the resources that we have. So as I mentioned, you have a virtual name. So a virtual client access point here. If we were going to have applications that were going to leverage this cluster, they would go ahead and connect into dev SQL cluster. And it would use the IP address that's specified down below. So everything we're going through here is same subnet here to try to keep this as easy as possible. The whole point here is if you have an application, they would connect into dev SQL cluster, so regardless of which node is currently hosting the instance, they always connect through the exact same name and route to the same IP address. So the next thing to show is that we have storage that's set up. So this is shared storage, and it's going to be contained to the group that it belongs in. So these disks can only be included inside of the SQL Server group that we've configured here. So if you had multiple instances that you would want in the Failover Cluster instance, you would have different pools of shared storage for each one. You couldn't have one and share it and have it used between both of them. And then down below here, you'll see the resources that are online here as part of the SQL Server cluster. So this is where if you wanted analysis services configured, the database engine and the agent, these would all be resources that would be used inside of the Failover Cluster instance. And of course, you could have others that would be optional in here, like an example could be a file share. So talking about quorum here. So in mirroring, we saw how you would use what was known as a witness to kind of act as a quorum to help make sure to see, if we should fail over or stay online. In a Windows Failover Cluster, we have a quorum configuration that does this for you. So there's multiple options in here. So for example, if you have an odd number inside of your cluster of servers, of nodes, one option that may work for you is node majority, because that way you always will have an odd number of votes. So if you actually had 3 nodes in your failover cluster and one of them failed, you would still stay online because you have a majority vote. Some other options that are in play here is you can actually use node and disk majority. So this is really extremely helpful in even number cases, where this uses the disk witness as an extra vote, so that way you have that odd number of 3. So you can actually set up a shared disk that would end up being used for this, or you can use a file share if you would like. So instead of actually carving out shared disk and having it set up for this group that we would use for our failover cluster, you can actually use a file share. And also, if you really wanted to, though it's extremely not recommended, you could do no majority at all, so you wouldn't use node disk or you wouldn't use node majority either. So here's kind of a high-level look, once again, at failover clustering and how it'll work for you. So here's an example where we have 2 nodes. We got 2 servers running. The one on the left in green is actually live online right now. And you can see it's pointing there towards the same storage. So if we actually had a failover or we wanted to do a maintenance patch, what would happen is we would fail it over. So we can switch it over, and you can see now that the right server instance there is online in green. Our storage is up, and we can see that we're restarting and our server on the left is down. So we're have a very small impact of flipping over from there, and we're good for being highly available. So what happens if you lose your shared storage? This is kind of the biggest con to failover cluster instances. If you actually lose your storage for any reason at all, you basically have a useless failover cluster, because as I showed you, the storage is contained to its single group, and if you can't access that, then nothing inside of the group would be able to use that storage. So you basically would have 2 servers that are completely online but are not useful for you because they're not accessing your shared storage. So a couple pros and cons with failover clustering here. Once again, this involves multiple servers, so we have multiple servers that are in place here. Failover clustering allows protection for the whole entire instance. So once again, you don't have to worry about database level and instance level objects. For example, your SQL agent jobs, your logins. They're all included as the system databases, and the whole instance are included in your protection here. You have automatic failover. So as I mentioned, if you lost one server, it could fail over to the other. You have transparent connections. So once again, you're using that virtual name to connect in. So that way you're always connecting to the same name regardless of which server is hosting the failover cluster instance. Some cons here is you could potentially have idle hardware. So as I mentioned, a lot of configurations I see out today will have a 2-node cluster, which is referred to as active-passive, but what it really means is just You have one instance and you have two nodes. So the instance is only going to be running on one, and you basically have another node there just for failover that's not being used. As I showed you through the slides here, that shared storage can be a big problem with failover clustering if you ever lose it, because it'll cause your whole group to go down and be your single point of failure.
Okay, we do have a couple of questions if this is a good break point for you.
Sure.
Okay, got a comment from Michael. Basically, the gotcha for transactional replication is that you also need primary keys on your tables. Do you have any comments on that?
Oh, yes, that is true, and that should be added in there. So you do have to have a primary key for transactional replication for your tables that you would end up using as articles. That is correct.
Okay, the next question here is, with high-performance mirroring, how can you tell what transactions may have not been committed to the mirror if there's a failure to the mirrored node?
Can you repeat the question there?
Yeah, basically if we're doing high-performance mirroring, so asynchronous, and the mirrored node dies, what mechanism can you tell that what didn't get replicated in time?
Oh, gotcha. So there is a tool inside of Management Studio that you can use for monitoring, and there's also perfmon counters that you can get into. That's kind of a lot more outside of the 100 level for this, but those would be a good starting points, and of course you can use your T-SQL statement to do the actual failover in that scenario.
Cool. Okay. Are there any limitations to the number of users connecting to a failover cluster or mirrored instance?
Failover cluster mirrored instance.
Yeah, and it's really there shouldn't be any additional penalty for the high availability stuff with the number of concurrent users connected.
Yeah, correct. I was just a little thrown off because it seemed like a couple were maybe combined by how that was worded. So I wasn't sure if we were even talking about failover cluster instance or mirroring.
Yeah.
But yeah, that is true.
Yeah, and it's a little bit more of an advanced question, but in using failover clustering with Windows and SQL Server 2012 standard, can you do geographically diverse clustering, so different data centers, different locations? And it's more of an advanced question there, but the answer is yes, but with a lot of gotchas.
That is correct. And in fact, we're even having a presentation in a couple months that goes into a deep dive on that. But yeah, the complexity of that goes up quite a bit.
Cool. So I would say the answer is yes, asterisk, asterisk, asterisk. Stay tuned for December with Edwin on that one. He'll go into the deep dive on that. The last question here is, can you have more than one instance on a failover cluster? And if yes, do they require a separate virtual name and IP?
Yeah, so in a failover cluster, you can have multiple instances that would be there. But yeah, you would need to have different named instances, so they couldn't be the same, and you'd use it. Right, so it's a completely separate group. Each instance would be treated as its own group, so you'd have separate virtual name and IPs for those also.
Cool. Okay, and the last question is, with the failover cluster, does it contain copies of things like logins, agent jobs, things like that?
Yeah, the failover cluster, the whole instance is included. So everything inside of the instance would be included in failover and be seamless for the end user.
Okay, and we'll save that last question for the end. We'll let you go ahead and keep rolling.
Okay. So next I'll take a quick look at availability groups. So availability groups is a new feature that was added in 2012 that kind of gives us some of the best features of mirroring and clustering together. So here's an example where we're going to have actually our failover cluster. So a failover cluster is a prereq for setting up an availability group. And so instead of a failover cluster where the whole entire instance is included, Here we're actually doing this at a database level. So our transactions are being, based on insert, updates, and deletes, are being sent over to your secondaries on different nodes. So to kind of keep this example very simple, we obviously only have here a 2-node example where we're going to have one database where the primary on node 1 is going to be sending its data, whether you choose synchronous or asynchronous, over to node 2. So in this example here, I'm showing you 2 separate data centers. So here's an example where you definitely probably want asynchronous. So that way we're actually sending the data across from one data center into the other. You can leverage what's known as a listener here. So the listener will actually act similar to your failover cluster, where you would actually have a virtual name and IPs that you would end up using to connect to the read-write replica. So the read-write would be our primary. This is where our reads and writes are occurring. And then from there, the data would be sent over to your secondary, which would be over in node 2 here. And depending on how you configure this, you can have readable queries firing against it. So as I mentioned, a couple problems that we've seen, for example, with database mirroring is that you couldn't group databases. So if you actually have an application where you have multiple databases that are used by this application, each database would be treated separate. So you could potentially have a scenario where one database fails over, but the other one doesn't for the application. Inside of availability groups, you can now actually group these databases so they're treated as one group. So that way all the databases for an application would fail over at the same time. So also in database mirroring, you only get one mirror copy. So this one database can get mirrored. You can't have more than one backup copies, where in availability groups you can have up to 8 replicas inside of 2014, so that way you can have multiple locations where your data is going to be for keeping it highly available. Also inside of mirroring, unless you're using a snapshot, a database snapshot in Enterprise Edition, you can't read the data at all. And that can be kind of complex to manage, especially if you need to keep changing how frequent that data is being able to be read from. In availability groups now, you can actually have dedicated readable copies that are constantly available for queries access. So the other nice thing here is with mirroring, you needed actual witness. So you needed a whole separate instance to help you with automatic failover, where we're going to take advantage of the actual quorum inside of failover clustering. So as I mentioned here, just stated again, some of the benefits here is we're not relied upon shared storage. So when you look at your failover clustered instance, you have to have shared storage in those examples I kind of showed you, where everything's kind of contained in one data center and you're not doing SAN replication. Your listener, so just like how you have your virtual name that you connect to in a failover cluster, you can leverage a listener and actually route traffic. So you can set up and tell it to route your read traffic inside of there. You also now get your multiple replicas. So you have multiple copies that can be used for different purposes. And they are readable. So you can easily go through and configure so that way you have copies that could be queried. So if you have, for example, requirements to where you need to keep data online, but you also have some other requirements for some ad hoc readable queries you don't want to affect your production read-write traffic, you can also do that too. So with always-on availability groups here, you have to have Enterprise Edition, so this is definitely a costly feature. So every single instance will have to be Enterprise Edition. You'll have to have a Windows cluster that is configured, as it's a prereq. It sits inside of the the Windows cluster. For example, it leverages your quorum to help you with automatic failover if you're going to end up using that feature. You have asynchronous and synchronous modes, just like you would see in database mirroring. So you could have synchronous, so that way you can choose to use automatic failover, or you can do asynchronous for performance. The databases will fail over as a group, so that way you can actually have a contained group of databases for an application, and they're all treated as one. You no longer need shared storage, as you're actually going to leverage your storage that's presented in each instance that you're using on that server. And you'll have the readable copies in 2014. You'll have up to 8 replicas that you can use. So a couple of gotchas, especially if you're working with an existing instance of SQL Server that's being used, is you actually have to go into the properties of the database engine and you have to enable it, and the enabling it by clicking on the checkbox won't take into effect until you actually restart the instance. So that's one thing to note here, is you could potentially have a downtime. I've asked a couple of times at some conferences to see what actually goes on behind the scenes here, and I haven't gotten a great answer yet. But we do require a downtime here if, for example, you have an existing production instance and you want to enable availability groups. So you will have to restart for this to go into effect. So taking a quick look at availability groups. So this is what you would see when you have one configured. So we're going to focus on the SQL Always On availability group here. And you'll see that we have two replicas. So this is kind of mocking our example that we walked through at the beginning of this section. We're going to have one that's your primary. So this means all your read writes would go over to that SQL 2012 prod 1 instance. And then we have a secondary copy over there for high availability. So that way if our instance went down for any reason, then we could fail over and be brought up on our DR server. So in this case, I'm mocking an AdventureWorks application where we need two separate databases here. So we have our AdventureWorks 2012, your AdventureWorks Data Warehouse 2012, and these are all treated together as one group. So that way, if one of the databases had to fail over, then you can actually go ahead and both will fail over. So you will run into that scenario where one database for the application failed over and the other one didn't, which you could potentially have in mirroring. And then we also have our listener here. So the listener, this is that virtual name. So regardless of which instance is primary and holding the read-write copy, you can always connect to this listener, and the listener will keep everything online, will be used for connectivity. So regardless of which instance is online, you could always connect in through the SQL 2012 availability group listener. So a couple properties that you can go through while you're setting up your configuration. So once again, your availability mode, this is where you can pick your synchronous or asynchronous. So remember, in database mirroring, this was high safety and high performance. If you do select synchronous, then you have the opportunity of using the automatic failover. You can also control here what kind of connections are allowed in the primary role. So for example, you could say that only read-write traffic is allowed, or you could specify whether you want all connections. So read-write, or also if you wanted read connections, that those can be included over there. So also there you can determine whether you want to make a replica availability for reads. So in this case, we have here where we're showing here where you can configure yes or no for that, and also you have your timeouts. So how long for a timeout to occur can also be configured in here. Where if you're looking at database mirroring in the past, you'd actually have to set that up with T-SQL. That's not even an option that's configurable through the GUI. So you also have a dashboard here. So if you wanted a quick look at the health and state of your availability, you can go to the dashboard inside of the graphical interface. And this will give you a good view, letting you know exactly, what is the state, which database is primary, or which instance replica is primary, which ones are secondaries, what mode they're in, and what's their current state in there. So for example, here you can see it's synchronized, and because we're doing our synchronized mode here, that we have it for automatic failover and there's no data loss going on. So some pros and cons here for availability groups. Once again, the no shared storage. You now actually have readable secondaries that are easy to configure and don't require a lot of work for setup. The administration, it can be done through SQL Server Management Studio, so you actually don't have to do a whole lot of interacting with the Failover Cluster. That you can set everything up for failovers inside of using T-SQL or the GUIs. Configuration isn't that hard. And of course, you can group your databases together here for setup. Some cons to availability groups is that it's an enterprise-only feature, so you'd have to have Enterprise Edition on every single instance that you would use inside of your failover cluster for availability groups. It is a newer technology, and as DBAs, kind of up until this point, we probably didn't do a whole lot with failover clustering, and this is a case where you're probably going to be involved more, and you're going to have to do a lot more with failover clustering and kind of understand at least the basics of it while you're responsible for your availability groups. And also, you have app code changes that may be needed, so you may need to have some code that's built into your connections that has you doing retries when you have a failover that occurs. So the slide deck here, if anybody wants a copy of the slide deck, you can go to this link here and download a copy of it. Also, if you have any questions at all, you can shoot me an email over at john.sterrett@linchpinpeople.com or shoot me a tweet or anything, and I'll be glad to help anyone that has some questions about coming up and understanding the features inside of SQL Server that are built in that you can leverage for creating a high availability or disaster recovery plan.
Awesome. Thanks a lot. Do we have any other questions? There were a few more that came in, but I answered them in the chat window. If we don't have any more questions, thanks a lot, John. That was really, really good. And I know we're going to be doing a deeper dive on a lot of these topics over really the next year.
Exactly.
Cool. Okay. Well, I don't see any new questions. So thanks for attending, everybody. We really do appreciate it. And we'll see you next month after the SQL Pass Summit for Brendan Leach. Thanks a lot.
Yep. Thanks, everyone.